Combinations are selections of items from a collection such that the order of selection doesn't matter. So they're very similar to permutations, except in a permutation, the order does matter, where in combinations, the order doesn't matter. The notation for combinations you can see in two different ways. The way that will show up often, especially on like a calculator, will be NCK, or that can be equal to, in parentheses, n over a k. But what this means, if you see this notation, how to calculate the combination is n factorial over k factorial times n minus k factorial. Let's do an example of this. In a game of musical chairs in a single round, there are 5 people but only 3 chairs. How many different combinations of winners can make it to the next round? So if you've ever played musical chairs, you know that the order does not matter as long as you make it to the next round. So this is a combination question, not a permutation question, because again, the order doesn't matter. So we can write this in combination form, like 5 choose 3, which of course is identical to this, which is also read as 5 choose 3. And that's going to be equal to 5 factorial over 3 factorial, 5 minus 3 factorial. So, of course, we can do this on a calculator. In fact, there's on graphing calculators, there's just a button for combination. So you just type in 5 and then the NCR button and then 3. Or you can use the factorials. So we can do that, or let's just map this out so you understand it conceptually. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1, because 5 minus 3 is 2, and 2 factorial is 2 times 1. So then we would see that the 3, 2, and 1 cancel on the top and the bottom. 1, of course, doesn't really matter. And then we have a 2 that we can cancel with the 4, so the 4 is going to become a 2 now, and the 2 on the bottom will disappear. So 5 times 2, that's going to give us a total of 10. So then our answer is simply 10. Okay, that's great. So on the ACT, if you get a combination question, sometimes they will ask you to compute the final answer. Other times they will ask you to plug in numbers or actually write out what the formula is and not solve it. The reason why they do that is because they know that most people have calculators and can simply put in 5 choose 3 on a calculator and get the final answer. But they might not know the formula for solving it, so sometimes they test our knowledge on solving formulas. Of course, if you want to understand combinations more intuitively, the other way to think about this, just so you can understand how combinations actually work and where that formula came from. So intuitively for this question, you want to figure out the total number of ways that we can arrange people in the seats, and that's actually a permutation. So that would mean the order matters. So that would be 5p3, which, if we're using the fundamental counting principle, that's just 5 times 4 times 3, which is equal to 60. There are 60 total ways that people can be arranged in the chairs if we have 5 to start and only 3 chairs. And in that case, the order would matter. But we know that the order doesn't matter for a game of musical chairs. What do we do to get that 60 to turn into that 10? Well, once you have 3 people, and it doesn't matter what 3 people, once you have 3 people in the chairs, how many ways can you arrange 3 people in 3 chairs? So we can arrange 3 people in 3 chairs, which is 3 permute 3, which is equal to 3 times 2. There are 6 ways to arrange any group of 3 people in those 3 chairs. So what we do then is we take 5p3 over 3p3, and that is going to give us our answer, which is equal to 10. So you can do it that way as well. So intuitively, you divide the total number of ways to arrange 5 people in 3 chairs by the total number of ways to arrange 3 people in 3 chairs. And that's the same as doing a combination. It's just 2 permutations. So regardless, hopefully you know a little bit more about combinations and can answer the questions based on at least the formula or at least intuitively.